In this video, we're going to look at an example of computing a gradient and using it to find a rate of change. So we're given the function f of x, y, z equals y squared e to the xyz. We're first asked to find the gradient, we're asked to evaluate the gradient at a particular point, and then we're asked to find the rate of change of the function at that point in a unit direction. So again, to calculate gradients, we take the partial with respect to x, y, and z and multiply it by I, j, and k respectively. Remember, the gradient is a vector. The partial with respect to x is y cubed z e to the xyz. Multiply that by the I. We'll have to use a product rule to take the derivative with respect to y. We get a 2y e to the xyz plus an xy squared z e to the xyz. Multiply that by j. For the partial with respect to z, we'll get an xy cubed e to the xyz, and we'll multiply that by k. So that would be our gradient vector in this case. Finding the gradient at that particular point, we just need to put in 0 for x, 1 for y, and negative 1 for z, and we should get the vector negative I plus 2j. Finally, to find the directional derivative, the rate of change at the point P in the direction of that unit vector u, that means to find a directional derivative. We have the gradient calculated, we know the unit vector, so now we can just do the dot product of the gradient and the unit vector to find the rate of change that we want, and in this case, if you go through the arithmetic, you should get 5/13.